as Omo mentioned, my name is Roger, and I'm here today to talk about consumer drones. Out of curiosity, does anyone here own a drone, like a quadcopter Phantom, or like no one? Okay. Well, look around because that's going to change in the next couple of years. Okay, so the topics today are going to be, what is a consumer drone? I'm going to talk a little bit about the consumer drone market. We'll talk a little bit about multi-rotor drone architecture, which basically is a fancy word for saying, you know, how drones are made and how they work. And also, if you guys pay attention really well here, we can even build one right on Hobbyking. So you guys can, like, you know, actually put one together, and you'll know whether or not you know how to build a drone if, you know, turns out to work out. Okay. So, what is a consumer drone? Well, the consumer drone is definitely not the pictures of the drones on your left, right here. This one is a Predator. It's made, I believe, by General Atomics, if I'm not mistaken. And the bottom one is made by Boeing. It's called a Phantom Ray, and it's also a drone. These would be considered consumer drones right here. This one's called a Hexo Plus. It was actually a Kickstarter drone that launched last June. In 30 days, it actually cleared, I believe, 1.3 million in funding on Kickstarter. This right here is a 3D Robotics Iris Plus. 3D Robotics is a drone company in Berkeley. If you think of Silicon Valley drone company, this is the company you're thinking of. It's called 3D Robotics. And then this one right here is called the Parrot Bebop drone. Parrot is a French company. So yeah, like pretty much easy to distinguish one from another. I want to talk a little bit about the difference between a drone and an RC aircraft. RC aircrafts have been around since, you know, the 80s, maybe even the late 70s. It was a very expensive hobby back then. The price has come down. Really, an RC aircraft, what it's doing is you control the, I guess, the aircraft through just like the radio spectrum, and it's live control. What that means is that you're controlling, you know, your aircraft live. So if you do anything like you mess up or you lose sight of the aircraft, you know, it's on its own. So, you know, it's not really. The thing that really distinguishes an RC aircraft from, I guess, you know, a drone, an autonomous drone, is drones typically have GPS and they have programmability. What that means is you can actually pre-program flight plans into drones. And, you know, you do that off of your PC or even off of your tablet. The really neat thing about drone flight is you can actually change the flight plan while it's in flight and upload it, you know, via tablet or even via your smartphone too. So there's a lot of other neat things about drones. Like the cool thing with GPS is it's really forgiving. Like if you try and fly a quadcopter without GPS, it's really difficult. Like even with just stabilization with the gyroscope and accelerometer, you can get balance, but if a gust of wind blows by, with GPS, the drone will actually autocorrect and go back to the point it was before the wind hit it. Without GPS, that RC craft is going to keep on drifting. And that's really bad if you're in a very heavily wooded area because you're going to hit a tree. So yeah. The consumer drone market. Okay, so by the way, if you have like any questions that you really want to ask, feel free to interrupt me. Just raise your hand. And the consumer drone market. Okay, so these are the big three. DJI Innovations. This is the recently released DJI Phantom 3. This was actually announced last week. So, you know, this is pretty much on the cutting edge of DJI's, you know, product lineup. It looks a lot like the Phantom 2. It looks a lot like the Phantom 1, but it has a few extra electronics on there that give it a little bit more of an edge than the previous generations. This right here was actually announced 2 days ago, and this is by that American Silicon Valley company called 3D Robotics. This one is called the Solo, and this is also going to be a really exciting drone. The neat thing about these two drones is they're really trying to bleed into the effect of being able to use your smartphone. So it has connectivity to your phone, and through that it can actually connect to the internet. mind you, it does not have standalone GSM, antenna on there. Like the drone by itself cannot connect to the web, but it can through your smartphone if you have your smartphone with you and you pre-program it. And yes, this is also the Parrot Bebop drone by Parrot, which is, I guess, be considered their flagship model right now. Okay, so this is kind of a case study of DJI Innovations. DJI Innovations is a company based in China, and I think the province is it's in, I think it's called Shenzhen, if I'm not mistaken. Yeah, so this company founded in 2011, their first year, really tiny company. They did $4 million in revenue with the first like early drone kits. And mind you, I worked with a drone kit. That was my first experience in drones in 2012. It wasn't fun because I'm actually, I forgot to mention it, I'm a mechanical engineer. I graduated this past December. And, I'm really good with mechanics. Back then in 2012, I just took an introductory level to electronics, really weak in programming and all that stuff. So it wasn't a really fun case for me. I really didn't know what the heck I was doing. And yeah, so that was back in the day in kit form. And I really like to compare drones to computers because early personal computers were actually delivered in kits. It wasn't a complete package. So that was really cool. Okay. So DJI, first year in business, selling their kits, $4 million in revenue. 2012, they got a little pop. That year, 2012 in revenue, they got $40 million, which, hey, that's really fast growth. And then in 2013 is when they introduced their Phantom 1. Now the Phantom 1 always makes it on CNN. Whenever you see a white drone that's a quadcopter, if you don't know what a quadcopter is, we're going to explain that in later slides. If you see a white drone, more than likely it's a DJI drone. The quadcopter that crashed into the White House was a Phantom. So, it's just, it's one of those drones that it's like, they call it the Apple II, computer of the drone world. So these, really young and everything. So yeah, no, in 2013, their first full year with the Phantom on the market, they popped up to $140 million. So wow. Year 1 in business, $4 million. Year 2, $40 million. Year 3, $140 million. Their last year, 2014, they cleared $500 million in revenue. So they're growing really fast. Companies that grow this fast, they're typically called startups in hyper-growth markets. The personal computer in the mid-80s, late 70s was called a hyper-growth market. .com in the mid-90s was also hyper-growth. Really, whenever you see a company go from 0 revenue to $1 billion in under 5 years, they were in a hyper-growth market. That does not happen when you're selling tacos, in a restaurant or something. You think you're going to make it to $1 billion in sales in 5 years. That does not happen. It only happens in these rare situations. And yes, okay. So future growth of the market. A lot of people say that the market's probably going to be at about, the consumer drones is probably going to be close to $5 billion by 2020. Right now the market globally is about $800 million. So DJI, the Chinese drone manufacturer, owns about half of the global consumer drone market. And it really was because they were the first to market with a complete drone out of the package. Didn't need to program it, didn't need to know anything. You pulled it out of the box, you put it on the ground, you turned it on, it flew. That was really revolutionary for the time when it was released, because there's nothing really quite like it. And not only that, at the cost, it was only at about $1,000. Okay. So now we're going to talk about multi-rotor drone architecture. There's fixed-wing aircraft drones. There is boat drones. They're called unmanned surface vehicles. And then there's the rovers that they're unmanned. But really, for this discussion, I'm just going to talk about multi-rotor technology. And what really rotor means is kind of like, a helicopter. You put multi in front of it, that basically means it has multiple, helicopter propeller blades on the top. I'm going to go through a list of the more general ones. There's more fancier ones out there too, but, if you know these, you can say that you at least know the generalization of, multi-rotor drones. Okay, so the first one right here is called a tricopter. Anyone want to guess why it's called a tricopter? I mean, it's really basic. Anyone? Okay, it's because it has 3 propellers. Tri, 3. Okay, Okay, and then this is a quadcopter. Quad, 4. Okay, it's pretty basic stuff. Okay, so yeah, tricopter, quadcopter. And then there's another style called dead cat quadcopter. And the reason why it's called the dead cat quadcopter, you look at this, it kind of looks like a cat that experienced roadkill. And the guy who actually designed the source code, this is actually the real deal, this is his. He basically, you know, he loved his cat a lot, and, you know, after it passed away, he stuffed it and he put it on his drone and everything. And he actually changed the angles. Instead of it being completely, like, you know, perfect 90-degree angles right here, it's something like, I want to say this is about a 33-degree angle, and this one right here, it's like a 48. Like, they changed the angles slightly. And the main reason why they do that is because by having the forward arms further back, whenever you're videotaping, whether with your GoPro or whatever camera you have, the propellers aren't in your field of vision. That usually happens a lot with quadcopters. With dead cat quadcopters, that doesn't happen nearly as much. So you won't get that propeller in, you know, the top angles of your camera view. Okay? Hexacopter, you know, hexagon, 6 sides, you know, has 6 arms. It's pretty basic stuff, you know. And then I'm sure most of you have seen the Amazon, you know, Air Prime. They made a big fuss about it on 60 Minutes a couple of years ago. That's an octocopter. And generally speaking, something I want to mention, as you go up in rotors, it's really basic. You can carry more weight. But what you sacrifice is your drone becomes a lot more stable and a lot less acrobatic. If you ever see a drone doing crazy acrobatic skills, like there are drones that do flips, recover, you know, do all these crazy stunts, usually you'll see them in tricopter or quadcopter form. You will never see them in an octocopter form. Octocopters cannot do acrobatic stunts, but they can carry a lot of weight, which is why Jeff Bezos from Amazon was like, you know, if we're going to have a drone delivery system, it's going to be with octocopters, 8 blades. There's other styles of drones as well that this is also considered a quadcopter. What they do is they basically install propellers on the top and propellers directly beneath it. So it's one will be rotating counterclockwise and the other one will be rotating clockwise. What that does for you is it gives you more thrust, and it also cancels out a lot of the tangential like turbulence and vortexes that you would get. Because usually when you have just a rotating prop going like that, the vortex going out of the propeller, it's in like that form. When you have another like rotating the opposite form, it usually cancels it out, so you just have a straight line of thrust. So that's a really neat thing about those. But it's heavier, you have more motors, you need more speed controllers. I'll explain what that is right now. Okay, so that might look a little confusing to you. Hopefully you'll be able to, I'll call you guys out on it at the end of the slide deck, and I'll ask if you can see if you can point out a few of these things and tell me what they are. These are the basics of multi-rotor architecture. I'm sure you can't read them in the back, but I'll run through them really quickly. And there's going to be a slide for pretty much each one, so don't think that this is the only time you're going to see these terms. What you usually have in your drone, you'll have your flight controller, which is basically your computer. It has, you know, the microprocessor, it has the built-in accelerometer, it has your barometer, like it has all those cool, like, you know, sensors like the magnetometer with the compass. You have your brushless electric direct current motors, or you can just call them electric motors. You have your electronic speed controllers. The speed controllers, or the ESCs, no one really calls them electronic speed controllers. That's like the real technical term. Everyone in the hobby community calls them ESC. They're like, oh, what kind of ESC you have? It's the acronym. You just use it. Just like, you know, no one calls laser by its real name, which is light amplification by the stimulated emission of radiation. That's LASER. No one says that. They're like, oh, laser. Like, you know, so usually it's a wicked acronym whenever, you know. Okay, so and then you got your lithium polymer battery. Everyone calls them LiPos. Your GPS module, your frame, your propellers, and your radio transmitter and receiver. Some people don't even need your radio transmitter and receiver. If you've got a tablet and you got a telemetry kit, you basically don't need that because you can actually fly your drone with your tablet or your phone. So that's pretty cool. Okay, flight controllers. Like I was mentioning, you know, flight controller is basically the brain of your drone. This one right here is an open source flight controller. I use it all the time. It's called ArduPilot. Because it's open source, it's developed by the community, so it's always getting updates, and it's free. The only thing you really have to pay for is your hardware. Software is free, so you know you can That's really good. Like, it doesn't hit your wallet as hard. This one is by DJI. DJI Innovations, the company I was talking about, the juggernaut from China. This is their flight controller. It's called the NASA. It also comes with the package, the little GPS module and everything. And the flight controller here, like I said, it's open source, but the people that have really taken it under their wing is 3D Robotics in California. This is usually the flight controller they use, or they use another one called Pixhawk. So, I guess if you would say American, Chinese. Okay. So, yeah, that might be a little bit intimidating. If you don't want to look at all this crazy stuff on the right side, that's okay. But people who are, a little bit more, electronically savvy, I'll explain this right now. Okay, so electric motors. There's really only 3 things you need to know in your brushless electric motor. This right here is an example of an RC brushless electric motor. You're going to see 3 values. You're going to see kV. You're like, okay, now what's kV? Hold on, I'll show you right now. Okay, so you'll see a kV number on your motor. It'll say 800, 1000, 2000. Okay, you're like, what the heck does this mean? Like, I remember one time a professor was like, kV means kilovolt, right? And I was like, no, it doesn't. not here, not on this motor. What kV really means is like, it's this term that whenever you multiply the voltage of the battery input going into the motor, that'll give you your your theoretical maximum propeller RPM. And so if you have like, I don't know, 800 kV motor and you have, a 10 volt battery, then that means the maximum output that that motor will generate with a propeller would be 8,000 RPM. So, that's really something that you need to know. Most often than not, it usually never reaches that, theoretical value, but it's good to know. Typically, high kV motors are good for high RPM applications. Lower kV is for lower RPM, more efficiency. So if you want a longer propeller, bless you, if you want a longer propeller, like let's say 12 inches, you'll want a lower kV motor, and that means like, it'll be able to rotate the propeller more efficiently with less current, and that'll give you a longer flight time. You do not want to have a big propeller on a high kV motor because it'll burn the motor out. Another thing is, the higher the kV, the lower the torque. The lower the torque, the shorter the propeller needs to be. Big propellers need more torque, so you need a lower kV. I'm sorry if it sounds a little confusing. Just remember, low kV, big propeller, high kV, small propeller. That's all you need to remember. Okay, so what is 1S, 2S, and 3S? You'll see a motor and it'll be 2 to 3S, and you're like, okay, what does that mean? Okay, that just basically tells you your voltage, and this is really something important that you need to know. Like lithium polymer batteries usually have standard voltages per cell. Like a 1-cell lithium polymer battery is always going to have 3.7 volts. Okay, 2-cell is basically, you multiply that by 2, 7.4 volts. 3-cell, 11.1 volts, and so on, okay? So really the only value you need to remember is 3.7. Just multiply that by whatever, this number is, and that'll give you the output of the battery, usually. We'll go right now in Hobbyking, and they pretty much spoon feed this for you, but I really want you guys to know the underlying, what the numbers mean. That way, I'm not just like saying, oh, do this, and you're like, well, what does it mean, Roger? Okay. So yeah, and then current, then current, obviously, you know how much current the motor takes. I'll go through this really quickly. 2 types of brushless electric motors. One's called Outrunner, one's called Inrunner. The only difference is the Outrunner has the permanent magnets on the outside. The Inrunner has the permanent magnets on the inside of the rotor. Typically, Outrunners will have better torque. Inrunners will have better RPM, and that's really, I know most of you aren't going to remember all this, but just so you know, okay, So right, drone architecture. What's next? Okay, so we have our motor. We also need our electronic speed controller. I was the idiot that had the motor, and I was like, okay, let me just connect DC power to this. That's not how it works. Brushless electric motors, they're 3-phase motors, and what that means is you need alternating current. Okay, so basically what an electronic speed controller does is it takes positive, negative DC power, converts it to 3-phase power, and that's really important. When you're building a quad, tri, or hexacopter, you can buy each electronic speed controller for each motor, or you can buy a board that has 4 of them already built into it. If you're a little lazy like me and don't want to do all the soldering for all these connectors, you're going to buy the one that has it all built in, because you just save a lot of time. And also space-wise too, it's good too.
Does that say 20 amps right there?
It's 20 amps per motor, so it can actually output a maximum of 80 amps per second.
Is that dangerous?
Oh no, not at all.
20 amps, no?
Oh, dude, I used to work with quadcopters pushing 340 amps per second. So like, that was dangerous, man. They used to scare the crap out of me. Okay, so yeah, next, Lipo batteries. Okay, you're gonna see, whenever you see a Lipo battery, you're gonna probably see 2 things that are really, really important. I already explained the voltage. The voltage is going to be right here. It'll tell you 3 cell. We already knew, what is it, 3 times 3.7, 11.1. So, but usually we'll have that written for you. You won't have to do any of the math. But it's going to have usually a number right here with C at the end of it. And it'll have a big number right here and another number right here. Usually the big number is just like it's a figure that it's measured in amp hours. Hold on, I'll explain it right now. Pull it up right here. Okay, when I first saw this, I really thought it was a measure of energy, like energy as in like something that you can spend, but it's actually a unit of electrical charge. I still, in my little head, I still consider it a unit of energy, because I can actually calculate how many amp seconds are inside of a battery, and based on how many amp seconds I know are inside of a battery, I can pretty much calculate how much flight time I have based on how many amps I know my motors are taking at a hover. So yeah, okay, let me explain this real quickly. Okay, so the C number, like the number you see with the letter C after it, that stands for capacitance. And if you want to find out how much current that battery can produce, like at each second, it's really easy. Just multiply this number with that number, with your C number, and that's going to tell you, okay, 6 times 25. I really can't do that well. Okay, let's see. 6 times 5 is 30. 20 times 6 is 180. So 180 plus 30 would be 210, right?
6 times 25?
Wait. What's 6 times 25?
150.
150. Okay, my bad. See? Yeah, that's what happens. Okay, I messed up right there. Okay, yeah. I don't know how to do math, and I'm an engineer. Okay. So, okay.
That's what calculators are for.
Yeah, that's what calculators. You see, they babied us with calculators. Okay.
It's like, the hardest stuff and the easiest stuff.
Yeah, basically. Okay, so 150. Okay, so then that means this this battery can produce 150 amps per second. So that's at a constant discharge. You see a second number right there? The bottom number always means how much it can discharge safely. So that means from full tank to battery out of energy, it can constantly produce 150 amps per second. In a 10-second burst, it can do double. It can do 300 amps per second for 10 seconds. If you do it any longer than that, it's going to catch fire. It's happened to me. Okay, so don't do it longer than 10 seconds, because first you'll see smoke, and if it's in the air, you won't even see the smoke, and then it'll just it'll start burning. We've literally had, I've had experiences where I've had a quadcopter crash and burn because of the battery. Okay.
So you were showing the controller that had 20 amps. So that's already 20 amps.
20 amps per motor, so that's 80 amps per second that ESC can. Yeah. So you probably want a battery that could produce safely 100 amps per second. That way you have a little bit of cushion. But yeah. Okay. So as I explained earlier, right there, what does S stand for? 1S equals 3.7, 2S 7.4, 3S 11.1. As was shown earlier, you guys can do math better than I can, so you can just keep on going down. Okay. GPS. GPS is really important for a drone. I wouldn't even consider it a drone if it doesn't have GPS. If someone's flying, an RC quadcopter, they're like, oh, that's my drone. I'm like, does it have GPS? I'm like, no. Then I'm like, that's not a drone then. Okay. So, these are 2 examples. Usually it'll be in a nice little pretty case. On the inside, this is pretty much how it looks like. Usually when you turn your drone on, you want a couple of seconds for it to pick up the GPS satellite. if you're really impatient like I am, sometimes I don't wait that time and I'll start flying without GPS and I won't know I'm not flying without GPS. And all of a sudden, like, my drone will start flying in one direction, like, and not auto-correcting. And I was like, oh man, I don't think GPS working. So yeah, so that's bad news. Yeah, that's bad news, especially if you're used to that. Okay, so frame and propellers. This is a traditional, frame kit. It's a quadcopter, 1, 2, 3, 4. Here, in this case, you just attach motor. Your ESCs would probably go under here, or maybe if you choose to buy the board, you probably put it either on top or on the bottom. You put on your flight controller, then you attach your propellers. As you can see, 2 of these propellers are oriented in one direction, 2 are oriented in the other. The reason why that is because in your quadcopter, hexacopter, even tricopter, typically you want to cancel out like torque as much as possible. So if this propeller is rotating this way, if they're all rotating the same direction, you're going to have a little bit of a yaw because there's no counteraction in the drone. So usually you'll have your front propeller rotate this way, the other one rotate the other way, and it'll cancel out the torque motion, so it'll be pretty much stable. So that's why you'll have, you don't have all 4 of the same propeller, you have 2 of each. That's for a quadcopter.
What was the thing on the right? The attachments?
Oh yeah, those are basically attachments for the different motor shafts that you have. Like, they'll usually sell that in your propeller kit. Okay, and then your radio transmitter and receiver. It really depends on if you want to splurge. This one right here costs $3,000. It's for like the super, enthusiast that, that's like his main hobby and he really loves his, planes and drones and everything. But like I mentioned, we're moving into an era where this really isn't as necessary as it used to be. Before you needed this, nowadays you can actually fly your drone via tablet or via phone. So, I mean, it's really nice to get started off with this though, because this is basically like, when you're learning how to crawl before you do it on tablet. Okay, so, I guess I kind of wanted, before we build our drone on Hobbyking, okay, so we have this little box thingy here that is sending a signal to these, let me start on the outside, I'm sorry. Okay, what's this? You have, I guess a circle with 3 wires coming out, huh?
Brushless motor?
Yeah, that's right, brushless motor, good job DJ, okay. So, this right here has 2 wires going in, and it has 3 wires coming out, and also a little signal wire. What do you think that would be? Their speed controller, exactly. And this just has 2 wires, a red wire and a black wire coming out of its battery, of course. And then this box with the signal wires from the ESCs are all coming in this little box. It would probably be your flight controller. And what comes out of the flight controller, that little circle thingy? GPS. It would be your GPS, exactly. So, that's basic drone architecture right there. Before we build the drone on Hobbyking, do I have any questions?
When you buy the flight controller, does it already come pre-programmed, or do you have to flash it?
That's a good question. Usually you have to upload your own firmware, but the software is free. Like what you use for the Ardu Pilot, the black flight controller that I showed earlier, is called Mission Planner. And like I said, open source software, completely free. You start it, it's all point and click. It's really easy. Like it'll have like a hexacopter or a tricopter, you're like, oh, okay, a quadcopter, point click, point click, point click, point click. Before you know it, then upload, then it uploads it to your flight controller, you're done, pretty much. That's pretty much it. More questions?
That's the more basic one. Huh? That's like the more basic one?
A lot of them are really that forgiving, but some of them, like the one I had when I started off with, you program it with these little screws, and you shift it, and trust me, I had a horrible experience with my first quadcopter kit. I kept on emailing the manufacturer, was called xhealy.com. The worst customer service ever. Like I have never experienced customer service that bad. But and I said to myself, if I ever sold drones out, I would never treat my customers that way. But yeah. Yeah, no, so the point is, nowadays, they pretty much made it almost idiot-proof. Before, it really required a lot of digging in forums, a lot of, searching on, asking a lot of questions, Like this industry is really, really young. I would want to say that the personal consumer drone industry did not get started until the Phantom 1 was released in 2013. So putting that into perspective, you know, really the industry is only about 2 full years and a couple of months. It's probably like, it's definitely under 26 months, the industry. It's really young.
The 3 models that you showed up, the ones for Silicon Valley and China, what is the price of those things?
$1,000 entry for the Solo and for the Phantom. You can deck them out with like 4K cameras, with, you know, collision avoidance and with all this other stuff, but that's going to up the price. But like, you know, the vanilla version, you know, going in, $1,000.
If you go to eBay and you click like drones and stuff like that, you can
find
like
cheaper ones.
200. Like, but what about those?
You can, okay, the Parrot Beepop, the one they sell it on the Apple store. Believe it or not, it's called the Beepop. That one is for $500, and I was seriously considering buying it, but I did a little bit digging first. I was like, okay, it's got GPS, it's got a built-in camera that's really cool. What's the flight time? 6 minutes. I was like, please, I'm not going to buy a $500 drone for 6-minute flight time. That's another thing. The other 2 drones, they're mid 20-minute flight time. So like, you'll get like 22 minutes, 25 minutes with your GoPro. Really, in that class, there's no drone that flies longer than 26 minutes. Like, they haven't broken into the 30-minute flight time, you know, market yet.
Can I build one like
Yeah, that's what we're going to do right now. Okay, so, okay, let's
Well,
get on.
I was going to ask that is like, what's the price difference if you get like a Phantom versus building your own? Like, what kind of cost savings is?
A lot, actually, a lot. Like if you really want to build your drone and you want to spend $1,000, you can build a really cool drone because like you're basically not paying, you know, China or like Silicon Valley, you know, their money for their drone. But well, here we'll make one right now. I pulled up Hobbyking, so we'll get started right now. Okay.
Sorry, when you want to control it with a tablet or your phone, what kind of communication are you going to use? Bluetooth is like you cannot have a long distance.
It'll usually run through Wi-Fi.
So you create a Wi-Fi a hotspot between the phone and the copter, and all the communication going through.
That's usually how it happens. Those drones, oh actually I didn't really talk about regulation. I'll talk about that really quickly with the drone laws. Yeah, those drones, you're not going to get further than maybe like half a football field, maybe a football field max before you start getting spotty, like, you know, like lost and like, you know, control and stuff. Because, you know, Wi-Fi doesn't have that much of a range unless you have like a Wi-Fi network like in the megahertz range or something. Huh?
Using a Cantana.
A what?
Cantana.
Cantana.
Yeah.
What's that?
It's a Wi-Fi extension.
Oh, Wi-Fi extension. Yeah, you probably could, but yeah, no. So another thing I really wanted to talk about real quickly was the regulations. I'm sure you guys are seeing a lot of FAA like posting their laws. Man, I'm not gonna lie, guys. Like after the drone crash in the White House, that was before the first generation laws by the FAA were released. I was like, that's it. The industry's dead. Like, you know, there's gonna be like a vice grip on the, like, you know, law-wise. The FAA is not gonna allow anyone to do anything. They're a little bit lax on the laws. I'll tell you the few that I remember because I read through it and it was a lot of legalese. Okay, one thing, you can't fly at nighttime. That's one of the new laws. That's it, according to the FAA. Rule 2, it needs to be in your line of sight. That really, really irritated Amazon. So Amazon pulled all of its lawyers. The FAA now gave them an exemption to be able to try out their Amazon delivery system. But that's only Amazon right now. They're the only ones with the exemption that it really doesn't, I think, have to be in line of sight, if I'm not mistaken. And what else? Okay, you cannot fly higher than 400 feet. If you fly higher than 400 feet, you're breaking federal law, okay? So that's another thing that you need to be careful with. It's really hard to enforce that. I've seen people fly much higher than 400 feet. It's really one of those cases that you keep doing it till you get caught, or, you know, like, you know, or you keep doing it until it looks like you're about to get caught, then you run. But I'm just kidding.
So I actually have some info on that. The other day I was talking to an architect that was telling us that he calls the airport actually, and he lets them know that he's going to be flying the drone because the rule is 5 miles within
5 miles
proximity to the airport. You can't fly.
You can't fly. That's very true. In fact, Mission Planner actually has something called a geofence, where basically circles within like 5 mile radius of all airports. I live like you can't fly at Mach high, I can tell you that much. I live like on the outer edge of that, like, you know, I live right next to Calvary Baptist, and let me tell you this, like, I'm probably 200 feet away from the circle that divides the line that I'm not allowed to fly into.
It's
So,
pretty much half of McAllen.
half of McAllen, because, you know, we have an airport that's literally built, like, in the center of McAllen almost, or, like, you know, South McAllen. So, literally, like, everything south of Mach high, and I guess you would say everything west of 2nd Street and south of Mach high, it would be technically illegal to fly. But really, I mean, don't quote me. If you're flying under 50 feet, no one's gonna know. No one's gonna know. Like, you know, you still got the tree line and everything. They might think it's a seagull or something.
But apparently the Border Patrol and other agencies...
They're exempt.
Well, no, they're actually looking for them.
Oh, they are?
And they will report them.
Oh, wow, I did not know that.
So what he does is he calls ahead, though.
Oh, wow.
Because he can actually, well, it's pretty easy nowadays. You can fly track, you know? So he calls and says, as a courtesy, I want to do the following. I'm this far away. I'm within the 5 miles.
We can use that to control.
Well, that was an article, right? They were crossing drugs from Mexico to the United States.
Oh, yeah.
Yeah.
With,
No, there's a lot of them.
That was crazy.
Yeah.
But it's really not that cost effective to do it that way.
I don't think they care about cost.
Well, I mean, the thing is, these drones, they can't carry that much. Let's say you're smuggling, or you know, I don't want to get into that. Okay, so let's build a drone. Before I say something incriminating.
This was gonna get interesting, man.
Yeah. Okay. So we're on the Hobbyking website right now. Usually, what we'll start off with is.
What's up?
Here, I know, I was looking at how to scroll down the screen. Okay.
Oh yeah, 2 fingers actually. Use 2 fingers to gesture it
Okay.
on the mouse pad.
So right now we're on electric motors. We can choose in-runner or out-runner. Because we're using, like, you know, a regular, like, probably, let's say that we want to build like a quadcopter with 10-inch propellers. So we'll do an outrunner for this time, okay? You know what, I'm just gonna go through multi-star. Sorry, the refresh rates. Okay, so we'll click on the electric motors right here. And here they are. Sorry, it's still loading right now. What I usually always do is I always go by price because, you know, yeah, pretty much. Like, these are the more expensive multi-star electric motors. Really, like, I like using this brand of electric motors by Hobbyking because they're optimized for propeller aircraft. So yeah, no, like, always search for multi-star, I guess. Okay, so we were talking earlier about KV. Oh, you know what? Let's just buy it in kit form. Why not? Okay, so no. I'm sorry. I was trying to save time, but nah, we'll do it the right way. Okay, so here we go. We're looking at the different KVs. You see each motor 400 kV, 630 kV. I can tell you right now that the 400 kV motor, you probably use that with probably like a 18-inch big propeller, and that's probably going to be an expensive drone because look, each motor, if you need 4 of them for a quadcopter, each motor is $40. You know, 4 of them, that's already $160. Like, you know, that's going to be an expensive drone. So I would recommend that we wouldn't spend more than, let's say, $20 per motor. So let's go underneath the $20 price range. So we're scrolling down. Because you know the drones that you guys see, like the ones that I was showing, like the Solo, the Phantom, those are all using like $15, $20 electric motors. They're really cheap. So don't think that they're using like $80, nah. And Chinese are probably using motors that cost them like $5 or maybe less to make, so you know. So yeah, okay. We're already under the $20 price range. You know, this one looks pretty good. This is a 980 kV motor, so that'd be good for like a 10-inch or maybe even a 12-inch propeller. So we'll click on that one.
Is there a resource or graph to like say take a kV and translate it into wingspan? or the propeller side better?
There are calculators. There's like eCalc, like for drones. Really, some of them are pretty accurate. Some of them are not. Like I've used eCalc before, and it'll tell me like with this 11-inch propeller, with this motor, drawing this many amps, like it'll give me this much flight time. But really, it's one of those things that you gain from experience, like So this is right here a 980 kV motor. You can ignore the 14 pull. Really, all it says is pretty much how many teeth the stator has. And the stator is the inside of the electric motor. Okay, so we have an outrunner, 980 kV. Here are the values. kV is 980, LiPo cells 2 to 3S. So that means this specific motor can take a 2S LiPo or 3S LiPo. And if you remembered from the lecture earlier, 2S is 7.4 volts, 3S is 11.1 volts. Remember, I got that from the standard 1S 3.7. If you remember anything, remember a 1S lithium polymer battery is 3.7 volts. Everything else is pretty much multiplication. So if you see 4S, you just multiply 3.7 by 4 and it'll give you your voltage. Okay, this one can handle a maximum of 15 amps for 10 seconds. So it would be overkill to get like an electronic speed controller that's rated for 30 amps, because you're never gonna, that motor can't handle 30 amps. It can't even handle 15 amps properly. It's only for 10 seconds. So you're like, okay, we know that we need a speed controller for this motor that's under 15 amps, or like, 15 amps constant. So we've picked our motor. We want 4 of them. I'll just, put this on quantity 4. Don't worry, we will not buy anything, I promise. Okay. Okay, so now we added 14 motors to our cart.
It's loading.
Oh, okay. Yeah, okay. So next, what do we want? We want speed controllers. If you really want it easy, like you can go to the speed controllers on the bottom tab, or you can just go through the multi-rotor tab, and they'll usually have it right there. They'll even have your flight controller, your frame parts, and everything. If you just don't want to go through everything, or you can just search it here as well. Just type in speed controller. So we click on speed controller.
This kind of reminds me of back in the day when I wanted to create my own computer.
Exactly. A lot of people say that. A lot of people say that if you know how to build a PC, a desktop PC, you'll know how to build a drone. It's pretty much the same thing. Like, with a PC, you'll be CPU, motherboard, RAM, hard drive, video card, power supply, like, that kind of stuff. Like, if you know how to build PCs, building drones is like second nature. Okay. So you click on, your speed controllers. We're back to multi-star. If you want, we can, again, click on the price range. So what we'll do in this case, instead of buying one that has 4 speed controllers all on one board, we'll just get like, 4 of these, because the other way is kind of, Okay, so this one right here, this speed controller right here can handle a maximum of 20 amps per second, and the battery input voltage, it can handle from a 2-cell lithium polymer battery all the way to a 6-cell. So with this battery, with this speed controller, you would not put in a motor that's taking in like 10S, voltage, because it's going to burn out your speed controller. So, it's kind of like one of those things when you're, like you said with the personal computer, when you're getting your motherboard. I remember I made this mistake. I bought DDR3 for a motherboard that can only handle DDR2 RAM. And, it's one of those things that you need to be careful, because you can be like, oh, I got all my speed controllers, but hey, guess what? The motors aren't going to be able to handle it, or you did overkill. Okay, so let's see. This one's actually rather inexpensive. It's only $9. So, oh wow, but it's overkill. It's 30 amps. We don't need anywhere close to that. Here we go.
You're
Much better.
For 15, right, or less?
We're looking for 15 or less, but usually they have them in like 10, 20, 30, 40, so we'll have to get the 21. But we'll get the most least expensive, 21 available, and this one's only $8 per speed controller. Another neat thing is, if you really do want to save money, I would recommend you buy the board. because the board is less expensive. Like you're paying less. It's like $30 for 4 speed controllers on one board, and you know.
You just cut it.
You don't cut anything. It's already on the
It's
board.
one
Like
board.
it. Like I'll show you guys right now. Okay, so back order. Yeah, whatever. Okay, cool. So yeah, no. Here we go. This would be a the. Sorry, I'm not a Mac user, guys. Okay, here we go.
Hold that against.
Q brain. Okay. This one is the Q brain is the one that it's what it's called. It's basically the 4. You see the 4 speed controllers. It's built onto one board, and this one, I don't know why the images aren't loading. I'm sorry. This one's only about $30. Now, if you take the equivalent, that's 4 speed controllers on one board. If we go to the cart, we'll see that if we were to buy the 4 speed controllers individually, it usually costs more. And that was us looking for the very best deal per speed controller. Okay, so guys and gals, we have our motors, our speed controllers. Next, I guess we would check our battery. We saw that the motor, let's click on the motor again. We saw that the motor right there could handle anywhere between 2 to 3 cell battery. I figure let's go for 3 cells. That way, you know, we have a little bit more power. It's better. It's always better. Rule of thumb: it's always better to have more power than less power in drones, because you know I've had one of those awkward situations where we did not have enough power to get off the ground, and that was kind of sucky. So, like you know, if you're building a drone, always be like, okay, yeah, more power, more power, more power. Like you know, but don't go too crazy and build like a 10-cell super drone that can carry like you know a dog or something. Then that might be a little dangerous. Okay, so now we go to batteries and accessories. We click on lithium polymer. The neat thing about this is the Hobbyking website will actually let you select which like size battery you want, and we said that we wanted a 3S battery, so we just click that box. It refreshes. All these are 3-cell batteries. Okay. Now, we know that the motor, we checked, each motor can handle a maximum of 15 amps per second during the burst mode. So we multiply that by 4, and that's going to give us 60 amps. So we need a battery that at minimum can produce 60 amps per second. So what do we do to get that? We multiply, you know, that big number I was talking about by the capacitance. That needs to be more than 60. Okay, so this one actually has it for us right here. So 25C times, we divide that by 1,000 because we want amp hour, not milliamp hour. So that'll be 2.2. 2.2 by 25C, I'm pretty sure that's not.
50-ish.
Is that close to 60? No, it's no. It's close.
50-ish,
It's 50-ish, right? Okay. So that one would not be able to meet our spec. But let's go down. Okay. Yeah, I know we have to look for one that's got a little bit more oomph. Okay. Man, what am I doing here? Let me just go through the price range because right now it's not ordered. There we go. Now it's in price. Okay. So the top one, 40 times 8.4. That's way more than what we need. Let's see this one. 25 times 4. It's okay. You know but that's still a little bit overkill, right? we only wanted 60, and we're getting 100.
Some times tables.
Yeah. Dude, I used to have one in my room growing up. It's just that, you know. God, man. Okay, so.
Just in case you're stranded somewhere.
Yeah, I know, right? I'll be like, what's 1 + 1? Okay, so, yeah, man, a lot of these have a lot more current than we need. Let's see if we can find one that's a little bit more. Yeah, 5 times 30.
If it has more current, what happens? It just doesn't use all of it? Or?
No, the thing is it adds weight. Like, it's like saying that, like, you know, you have, I don't know, what would be a good example?
You're wasting the weight that you can carry all the things.
Yeah, it's like saying that you have a 1,000 horsepower engine in your car, but you only have a fuel tank that, I don't know, it would be reversed. It would be something like you have, I don't know. The point is like it's more than enough. Like your motors will never consume more than 60 amps. If you put in a 200 amp capable battery, all that's just extra energy that you don't need. It's just sitting there. So it's and it makes the battery heavier.
Yeah.
Like, you know, it makes the
More
battery
cells.
heavier.
Then probably the propellers won't be able to rise it too high. So
Yeah,
swap propellers.
exactly. So, man, all these there are a lot of overkill. Okay, for argument's sake,
These ones are still pretty good though.
yeah. Wow, 125 amps, man, a lot. You see, that's a cool thing though, because we don't need a battery that costs 30 bucks. We could probably get away with a battery that only costs $10. So, you know, as we go down, here we go. This one's good. This one's, oh, but still, that's 20 amps more than we'll need, right? That's 20 times 4 is...
I guess just take it though, because you still have the mission controller, what you call it, the flight tracker planner? Or
Yeah, that's true.
flight controller?
Hold
How
on.
much does that take up?
3 times... How much does the flight controller take up?
Yeah.
Price-wise?
No, the
Amps.
power.
Oh,
wise,
amps? Oh, it consumes nothing. It's like in the milliamp range. The motors are what, like, you know, are the most hungry in this case. Okay. Man, I'm just tired. I'm just gonna get this one, guys.
Sure, it's fine.
Okay, so this one is 5 times 20. That's 100 amps, right? Yes. Okay, so yeah, no, we're getting this one right here. It's 3-cell, which is the maximum voltage our motor will take. At a constant discharge, we'll be getting 100 amps per second. That's perfect.
25 bucks. John.
So yeah.
Could you repurpose these batteries for other?
Oh yeah. You can use these for anything, like, you know. So yeah, okay, we have our motors, we have our speed controllers, we have our battery. I'll speed things up right now. Let's get our frame really quickly, and then frame kits, why not?
If we wanted to print a 3D frame or a frame with you, could you do it?
Yeah, of course, I've done it before.
What's the cost?
Cost? Well, first I need to get my 3D printer working again. That's the upfront cost. But yeah, no. Remember I showed you the video of the Pegasus? That was the frame was all 3D printed, like, you know. So yeah. These frames are really expensive. We want the cheapest frame available for us. So we just keep on going down. It would be nice if you guys could see the pictures though. But take my word for it, they're pretty cool.
Sorry, I don't really know what's going on either.
Yeah. Okay, so here, look. Oh no, but that's really expensive. You should not pay more than 30 bucks for your frame, unless it's made of like really exotic
Well,
materials.
the first one I see that.
Okay. Here we go. This quadcopter kit, it looks like it's got everything we want, and it's for 30 bucks. In fact, it might be a little bit overkill, but yeah, no. Okay, so yeah, no, it comes with carbon fiber spars and a bunch of random stuff. And okay, so here we go. We got ourselves our frame. We got ourselves, now looking at our shopping cart, we have 4 motors, 4 speed controllers. We got our battery, we got our frame. What are we missing? We're missing our flight controller, our GPS, and we're also missing our propellers. So this is basically the knockoff of the Ardu Pilot Chinese version. It's called the HK Pilot, okay? The cool thing about this one is they sell it in kit form. So here we go. Perfect. Hobbyking, HK Pilot Mega, Mini. It comes with, what does it come with? It comes with gyroscope, accelerometer, magnetometer, barometer. It also comes with the telemetry kit. It has a GPS right here. You see it's got the U-Block Neo 6M GPS with the external compass. This little kit here has everything we want. It has a flight controller, it has a GPS, and it's only for 120 bucks. So, you know, we'll just add that there. Okay, so we got ourselves our flight controller. We have the frame. We have the battery. We have the 4 speed controllers, the 4 electric motors. Now, really, the only thing we're missing is our propellers. So let's go to propellers. Okay, here we go. Okay, now we got our propellers over here. Okay, so we said like this was going to be probably like a 10-inch propeller quadcopter. So in range, we'll go to 8 to 10 inches. Really can't see them here, but here, this basically, it's got two. Oh, this one's only 8 inches. No, we don't want that. Okay. This one is 10 inches. It's perfect. It's got two counter-rotating propellers, two like just clockwise propellers, and all that's only for $3. The most least expensive thing that you'll get in your drone is propellers, but I would recommend you buy more than one set because the rule of thumb is the first time you ever fly a drone, you're going to crash it. So you're going to lose your propellers. That's pretty much it's a guarantee. So yeah, no, order a lot. and yeah, okay, so we got ourselves our propellers. Yeah, you know what? Let's put two of them. That way, you know, we can. Okay, so look, you'll have a pretty. Excuse my language, but you'll have a pretty kick-ass drone for only $280. Oh, a radio and a transmitter. A radio transmitter. That's right. Hold on. Yeah, how are we gonna fly this? You know. Okay, so let's see.
Are you missing as well the GPS?
The GPS was in the kit. It was in the flight controller kit. See this one right here that costs $120? It's a combo kit. It's got the flight controller and it's got the GPS. It's got pretty much everything. So, radios. Here we go. Radios and receivers. We want a complete system. Okay, we'll click on cost. We'll probably get one of the low-end Turnigy ones. Let's see, they can be pretty expensive. We can get away with, you know what, actually we can even get away with this one. This one's a good one. And mind you, what Mode 1 and Mode 2 means is it's basically the side of the transmitter where you have the throttle. In Mode 2, the throttle's on the left side. Like, you know, to throttle down, throttle up, and steering is on the right. Mode 1, it's inverse, it's reverse. That's the only difference whenever you see Mode 1 and Mode 2. If you forget, you can just Google it. Okay, so here we go. This is you know, a complete transmitter. It comes with the transmitter and receiver.
What kind of transmission is this? 2.4?
It's 2.4 gigahertz transmitter and receiver. And
so,
it's
I guess a range of what, 100 meters maybe?
probably. And because it's Hobbyking and it's Chinese, maybe a little bit less than that. Because I've had experience where like I'll barely be like on the other side of a football field and it'll already start like, you know, acting really funny. So yeah, no. Like you get what you pay for. If it looks like a really, really good deal, and I would recommend, like, you know, one of the things that you should not cut corners on is your flight controller and your radio and transmitter, because the radio and transmitter is basically, you know, the response for your quadcopter, and like, you know, if it's a really bad one, you can crash and boom. What do you just, or let's check out the price. What do you just lose? You just lost $300, or, you know, minus the radio and transmitter because you have it in your hand. You lost like $290 worth of electronics. Okay, so here it is. You can build and assemble your own quadcopter from Hobbyking. That's pretty good. This is basically more or less the same thing that you'd be getting from the DJI Phantom or the 3D Robotics Solo minus the camera, and it'll be about $311, and plus shipping because you're buying this from Hong Kong, so it's about another $30. But you won't spend more than $350 on a decent, you know, drone.
That configuration is powerful enough to carry a camera.
Oh yeah, this one can carry a GoPro easily. Easily, yeah. This can carry a bunch of stuff, whatever you want. Yeah.
Are there any, have you heard of any insurances or anything you can do to like insure that this investment?
This is, I don't know, man, like, this is, I know a lot of the insurance agencies now are starting to use drones to survey, you know, like property damages and stuff. They got exemptions from the FAA, but in terms of insuring your drone, man, that's probably a pretty big business, because I can see, like, you know, I was showing you guys earlier that the market's right now is 800 million, and it's going to grow to 5 billion by 2020. I really think it's closer to something like 20 billion. And the reason why I say that is I can totally see at least anywhere between 5 to 10% of the first world population, like countries like Australia, Great Britain, France, the United States, Canada. I can totally see 5% of that population owning a drone by the year 2020. like, you know, easily. And that would be like maybe like a 20 or 30 billion dollar market. But they say it's going to be 5 billion, but I think it's more. And it's going to be way more if delivery takes off and Amazon is able to get its way. I mean, who here wouldn't want to say that I want to stay at home and I want my drone to go and pick up my milk for me, or I want my drone to go and pick up my McDonald's for me, or pick up my wings for me, or pick up like something for me. Like, trust me, like every technology from the automobile to the computer to, you know, the cellular phone that's been a success, it's made life easier. And by having a mini gopher go and get stuff for you, I think everyone's going to want to have something like that, like, you know.
It kind of reminds me to a certain extent the car that BMW just came up with, when it drives itself.
Oh yeah, yeah. Like, you know, that makes life easier too. Driverless cars, that's going to be a success because I swear to God, it's at least like 2 or 3 people on the way to going to campus every day, I'll see on their phone while they're driving. They're on their phone. So, you know, it's already like, you know, the market's there. People don't want to drive their cars anymore, you know. So yeah, no, like I said, every great technology that's successful has made people lazier. So, you know, and
can you share that shopping list in your website? Or
oh yeah, almost if you want. Yeah, if you want even a slide deck, like I can send it to you if you guys want to go through it again.
Is gonna put the video up on YouTube?
Yeah, the video will go up, and
just take a screenshot of it.
we can take a screenshot of this and post it on the Facebook group.
Good resolution to get that.
Yeah. Yeah, exactly. But yeah.
Take a snapshot of that.
Yeah, I'll do it right now. Any other questions for Roger? What do you plan to do, or go for it?
What was the thing that you said that you cannot fly your? What was the distance after certain limits? That you
can't fly higher than 400 feet.
And what is the reason for that?
Well, it's because once you start flying above 500 feet, you're going into like actual manned aircraft, you know, domain.
So you might just get like a jet engine.
But it's happened before. Like I remember before these laws were coming out. Like last year, I heard of like an RC. It might have been an RC. I think it was a drone because it could not be an RC aircraft flying at that altitude. It was like something like 3,000 feet. And like, you know, this freaking airplane drone just like zips by a 747 like right above Tallahassee, Florida. Like, you should listen to the testimony of the pilot. The guy's like, dude, it's like 2 feet off the side of my wing or something. And it's like, it's really crazy. And it was one of those like, you know, commercial airliners and stuff. And yeah, no, I was just like waiting for the first, you know, excuse me, dumbass to like crash into a building or a plane, and like the FAA basically being like, yeah, this is all illegal. Like, we're not gonna let that fly. Especially when the drone crashed in the White House in January, I was like, oh my God, like I really was terrified. I was like, dude, that's it, the market's dead because the FAA is gonna regulate it so much that any innovation in the market's just gonna die. But that didn't happen. The FAA was really lax on the rules, so you know, well, you know, let's see what's going on. Any more questions?
What do you want to do? Did you want to create like a business out of it, or what do you
Oh yeah. We're really close to our Kickstarter. We're trying to build a drone. The first, really, our drone. We want it to be the first drone in its class to cross the 30-minute barrier. And the way that we're doing that is pretty much everyone in the market right now is using plastics for their frame. And I can tell you, plastics is a really, especially like, you know, ABS is a really weak material to use for frames. Like, you know, it's based. If you're ever throwing a laptop off of you know, your roof or something, when it hits the ground, it's broken. The same thing happens to the drone. Just because it's a, you know, vehicle doesn't mean that when you throw it off your roof, it's going to be okay, and it'll break and it'll be gone. And the way that we're solving that is that we're trying to make a drone made out of. We're using all these exotic materials in our frame. We're using something called Spectra, which is a really strong fiber that it's actually stronger than carbon fiber. We're using another one called Xylon. We're using aerospace grade carbon fiber, and there's a difference. There's regular commercial carbon fiber, there's aerospace grade. And the difference is like aerospace grade can be like twice as strong as regular carbon fiber, like used in like cars and stuff. And yeah, no, like what we do is we have a really light, strong frame. We're even putting Kevlar in it. Really resistant, and we save so much weight by using composites. Like the typical plastic frame will weigh about 600 grams, like the complete frame, like the one that the DJI Phantom uses. Our frame's only going to weigh 300 grams complete. So we save a lot of weight, and that weight that we save we invested in a bigger battery. So our battery is basically twice the size of the industry 5 amp standard, and our drone weighs the same as everyone else. So we're going to get like great flight time. And like I said, the material is really, really strong. It's a publicity stunt, but I'm already like working on the math and stuff. But I really think that we could actually attach our drone to a weather balloon and drop it from space, near space, and it can hit the ground and it can still work. Like that's something that we're going to try. Because the terminal velocity I found out was only something like 3 meters per second, and Kevlar can dissipate the energy at 3 meters per second, like the frame. So if it hits the ground, like the Kevlar, the Xylon, the Dyneema, like all those super materials are basically going to prevent the frame from cracking. And as long as we have a really good dampening, like something inside that protects the electronics to like cushion the impact, it can still fly afterwards. So that's something that we really want to try and do. But like, you know, like I said, it's in the works right now, but I think it's possible.
I'll probably start with the chase building.
Yeah, the chase building. Yeah. We'll start something like that. But yeah, that's a good idea actually. We'll do that first. But yeah, no.
So who's your team right now? What do you guys need?
It's myself, DJ right there, and our computer engineer is this student at UTPA called Cooper. We're working on something else. It's really kind of hush-hush, but like I'll give you guys a little taste. And I really don't like hiding ideas. I believe ideas should be out there in the open. But the idea, like to me, like it seems so important that like, you know, I can't like let the cap off of it. It's basically something that we're calling fabrinetic, and it's an embedded like mesh physical net embedded inside the composite frame that allows the frame to have the sensation of touch. So you can actually like, you know, touch the frame and like it knows it's being touched. And it's a lot less expensive than touchscreen technology. We're looking at something like 4 cents per square inch, like, you know, for this net. And we're still working on it. Cooper, like, you know, he has like the rough prototype of like, you know, a fiberglass plate with like a curved surface with the mesh net inside. And all it really needs is like an Arduino Mini to like analyze the information that's getting from this network. We want to see if we can put that in the drone, but that's a kind of like a long shot. And also, believe it or not, like I mentioned earlier in the presentation, there is not a single drone available on the market right now capable of connecting to the internet on its own. So we really wanted to install a GSM breakout board so we can actually claim that our drone is the very first in the world with internet connectivity. So those are really the 3 things we're aiming for. Like quality material that can handle like, you know, a lot of abuse, best in class flight time at 30 minutes, and also like, you know, a digital frame with, you know, internet connectivity. And those are the main 3 things that we're working on. So we're hoping on I always say that we're going to have our Kickstarter like next month, but we really hope that we'll have a Kickstarter next month because, you know, student loans are going to start calling in the summer, so, you know, we have to have some kind of income.
Are you looking for interns or people that work with you?
Well, I mean, anyone that wants to understand the technology, that's cool too, if people are interested. But right now, really, it's a really lean team. Like, bringing people in and bringing them up to speed probably would take time from us, but I'm sure once we're in business, yeah, like, you know, if you guys are hungry and you want to come in, like I said, dude, this is a hyper-growth market. Oh, and something that's really crazy, you know, that the company DJI that I was talking about, something that really piqued my interest, and I knew that there's something special in this industry. The first time since Google, Kleiner Perkins and Sequoia Capital, the 2 most powerful venture capital firms, not in the country but in the world. Like, these were the companies that funded Amazon, Google, Yahoo, Instagram, YouTube, Cisco, Apple. Like, every time there's been a blockbuster tech company, these VC firms were behind it, but they never worked together. And this is the first time since Google, because they worked on Google together. DJI, they both put money in, and I was like, wow, like, you know, there's something special in that company. And it's scary though, because the Chinese company, usually tech companies, they start, you know, in the United States. Like the last 40 years, you have companies like Intel, Nvidia, Apple, like, you know, Google. All these are American companies, and it's the first time that the industry leader is not American, like in the last 40 years. Like, you know, it's a shift to China. China is the industry leader in drone manufacturing right now, at least in consumer drones.
Probably that the United States came up with it, but maybe too much regulation drove it out of here.
Yes, regulation. Bezos threatened to move his delivery system to the UK, and the FAA started listening after that. Like, he said that, and it was crazy. But
anyways, in which country the quality is better?
What do you mean quality? Like regulations? Australia is really last. Oh, do you mean quality? Well, I mean, I've already talked a lot of smack about China, but let me see. Like, the thing is, they're all made of plastic right now. Like, very few companies are actually using composites. And like, I'm a part of that camp that I believe composites are going to be really important, especially in the near future. I know that they made a really big breakthrough in mass production of carbon fiber reinforced plastics, like just like 3 years ago, and it was done in China. I mean, not China, in Japan, by this company called Teijin, and like both GM and Ford perked up when they heard about this, and Ford even went as far as to say that the 2020 Ford Focus was going to have an all carbon fiber hood, because before carbon fiber was in the realm of Ferrari, Lamborghini, because to make a carbon fiber part, the manufacturing time was hours, and Ford, to make a chassis, it's like minutes. Like, you know, they'll have an aluminum or steel chassis like ready to go like in a minute, 2 minutes, down the production line. They could not wait 3 or 4 hours while, you know, a part was ready. But like I said, they made a breakthrough a couple of years ago in Japan. They can now cure a carbon fiber part in under 60 seconds. So I really think that composites, really big, they're going to be really big, and, you know, I want the startup company that we're starting right now to have, you know, an edge in composites, because I really think everything is going to start moving towards composite materials like carbon fiber reinforced plastics and stuff, like within the next like 4 to 5 years, like computers, frames, you know, everything, because it's going to become so cheap. And many of you might be thinking, why are they, you know, putting all these exotic materials on cars? Well, the internal combustion engine's already maxed out in efficiency. Every time you get better fuel economy in your car, the hop from 40 to 50 miles an hour is not, they do nothing to the engine, because like they've already maxed out the theoretical limit on an auto like internal combustion engine efficiency. They can't tweak it anymore. So what they do is like, okay, what do? Reduce the vehicle's weight. How do we reduce the vehicle's weight? We use aluminum. That's what they did with the Ford F-150, the new one. How do we reduce weight more? We use composites. Like, you know, even for the new generation of vehicles, Ford isn't even putting replacement tires in their cars anymore. What they do is they're doing easy fix, like with the can, because they know they can save 40 pounds by not having a spare tire, like, you know, in the back of your car. Those 40 pounds, guess what? Instead of 30 miles to the gallon on the highway, you can now get 33 or 32, like that. So they're doing everything they can to reduce weight of vehicles now. And how can you do that? Composites.
Yeah, carbon fiber.
It weighs nothing. It's really light. Yeah. It weighs very.
It's a classic for the material of the 20th century, or the 21st century, and I think they want to make a ceramic. I forgot what it's called. Something ceramic within it for like this new as of 2010, like on 2020. Like.
Oh yeah.
And I forgot the name of the materials, but I know it's something ceramic. And they want to make that material like the new material.
Yeah, a really exciting material as well. It's called graphene. Graphene is making big ripples in the material world, because like graphene can affect, you can make better electric motors, you can make better, you know, semiconductors, you can make better, you know, like frames, you can make better everything. And all graphene really is it's just carbon, like, you know.
There are many new materials that are coming up. The things that for industry, until they can actually build it, they actually have to have like the simulation first, and because right now the scientists are doing like the actual things. Until they have the simulation, it's gonna be like not gonna do it.
Yeah. Any more questions, drone related or anything?
Yeah, one last question.
One last question.
So did you build this here in Valley, or what do you want to do? Or
yeah, I really want the manufacturing done here in McAllen. If I could, I would like to move, like, you know, like research and development maybe to Austin, because like we'll see what I mean. We're getting ahead of ourselves. But
Austin is the new
really has to do really has to do with recruitment, because like the thing is like we'll see what happens. Like in our first year of business, if we can recruit people from like Stanford or like Carnegie Mellon to come down here and like work with us, then yeah, we'll stay in McAllen. But if they're like, where's McAllen, or like, you know, where's, like, thing is like this young graduates that are really like, you know, hot stuff and really like, you know, just out of college and they're the best in their field, they really don't want to move down to the valley. They want to move to like really cool places like Austin or something.
Austin. Obviously, they haven't gone to the South Padre right now.
Yeah, there you go. All right.
They probably have, but they just don't want to do it.
All right, let's give our speaker